my stream. There we go.
Well, there's like 4 people. Oh yeah.
Yeah, well, let's build them up to a good, nice big number. Our zoom level is 100. What's 125? That's better. I can now see the whole thing without having to do the whole thing. So first off, it'd be useful to figure out what the parents are. So obviously, what are the genes of the dad? Just the regular genes.
W.
X, Y, and mom.
Y. Oh, no, X.
X.
Wait, is that this one?
X.
Okay, yeah. So figure out if you're a colorblind male, how do you change that? And if you're a trichromate, non-carrier female, please do that.
Make him do like principle of impossibility or whatever.
Oh, yes.
Just ask
Ooh,
him a
that'd be
random
good.
question.
Yeah.
Hello? Why? No, you didn't. You came late to class. Why are we late to class?
Is it X, Y thing? Yeah.
Oh, that's a terrible reason. That's trying to put it back on me. Try again.
Which one? Oh,
Yep.
don't know when to look. My notes.
You don't know where your notes are. Well, you can just copy this down. It's the last page. You'll be good. Okay, start.
Yeah, I got it.
Try again. This tutorial did not let you out on time, or you chose not to leave. Again, you're trying to be sad about another class I don't worry about.
Yeah, not as important as this class.
That's not as important as this class.
Brutal. They just want to learn.
They just want to learn, they can't learn.
Big kid,
5,
how do I know which one's
4,
colorblind?
3,
Oh,
2,
that's
1. Try again. Yes, and? Oh, excellent. Come on in. Sit down, get your stuff out. Some of you are even later than others, I noticed. There was only 4 people there a second ago.
I don't know who's that.
They get more credit than you guys do. Okay, we're on the last page. Colorblind male, trichromate female, put in the correct genes, and start.
Yeah, but how do I know, like,
Put your phones away.
if one of them, both of them are colorblind? Oh. Big R. Regular.
There is fairly pardon? So colorblind. We were using R, and capital R means normal vision. I trichromate vision. I'm trying to get away from normal because it implies people who are colorblind aren't normal. Of course, they're normal. Yes, they are. Don't insult Timmy that much. Where is Timmy? And Ben. So, capital R means that the gene is the regular trichromate gene. And lowercase r means that you have the mutated rods and cones. Matthew, did you find out about that other gene? That was in 10% of the cases or something?
16% of women, 8% of male. It's called tetrachromate.
Tetrachromate. So they have an extra.
Yeah. They have one.
So like a super gene.
Yeah.
That makes
It's
sense.
used for seeing yellows as oranges better.
Yeah. So apparently out there exists not just R and R, but like
But like more.
fancy R,
Yeah.
where you can see even better. Also, if you are female, I mentioned this last day, and you have both, you can see more colors because the non-trichromate gene, although it gives you less information, it also gives you different information. If you combine that with a regular trichromate gene, you can see better. I think, did I hear something?
No, that was the other door.
What's the new
Why would someone go to that door?
Not so close.
Oh, I see. Okay, first one. What should the genetics look like for the male? What kind of R?
Lower uppercase.
Lower.
Hands up for uppercase. Hands up for lowercase. It's a colorblind male. It should be lowercase.
Wait, what?
Oh, yeah.
If we could fix science just by voting on it, all of science, can you imagine? Let's repeal the law of gravity, and then boom, we all start floating. That would be amazing. They did a town in the States vote to make pi exactly equal to 3 to make math easier. Everything would be better. Okay, what should the female, genetic female look like? Capital R? On both?
Yeah.
Oh,
No.
no, it could be capital or lower.
If it's a trichromate female, I'm implying, I don't like the name normal. I apparently didn't. I am using that to mean regular vision, not a carrier. If it's a carrier, I'll say carrier. You are correct, though, that if someone can see just regular vision, you don't know if they're a carrier or not. Yes?
What's trichromate?
Means you have regular color vision. Tri comes from the 3 rods and cones, the 3 different colors. What are the 3 colors you can mix to that your elementary school teacher taught you that you can make every other color from?
Red, blue, yellow.
Red, blue, yellow. And that color theory is also completely wrong. Those are just the colors they have easy access to in elementary school. If you look at a printer, it's like cyan, and it actually has a better system. It's closer to the actual colors. However, even that doesn't work out quite as well because it's mimicking our biology. In addition, there's a color that doesn't exist because of your 3 color system doesn't actually show you reality. It shows you a guess at reality. You see a color that actually doesn't exist in any way. That's what technically purple is. If you look at a rainbow, you won't see that color. Okay, colorblind male, pop them in. X, R, Y. Traditionally, you put the males on across and the females down, but it doesn't really matter.
Like a trichromate female in this situation would have no carrier.
No carrier. If I meant carrier for this one, I would have said it. Although you are correct that if you just had regular color vision, you wouldn't know if you're a carrier or not if you're a female. If you're male, you either are colorblind or you're not. There is no such thing as a carrier for male. Also, every single one of these, what we're doing with Mendelian genetics, there are rare cases where it doesn't occur. So I told you last day when we did the blood typing lab that blood typing is as close to Mendelian genetics as you can get. And then I thought, is that actually true? Do we know anything more? And I went back and researched it. There are incredibly rare cases in which 2 type O people can have a type A person as an offspring. It's rare, and so there'd probably still be questions, but it is within the realms of possibility. Okay. Volunteer to read off what all the results are, and then we'll go through the percentage. No volunteer. Volunteer.
The first one is X big R, X small r.
Yeah. Oops. Just keep going.
X big R Y. X big R, X small r. And then X big R Y.
Okay. Let's start here. Percent that you'd have of to be a colorblind male. 0%. I'm just going to go straight through that row.
50.
Pardon?
50%.
50. I need to change my sheets. 50. And let's, here.
Me?
Ariel, yeah. Trichromate female.
0.
Wait. What? No, because if you have capital
Oh, is it
R,
25?
lower R, then for the 50, that because it's color.
Oh, I don't even know which one you're talking about. No, we just believe whatever anybody tells us.
But you just
Right.
said.
But
but
Nope.
you just said-
Nope, I'm just believing it. Zoe, next one.
Okay, carrier female would be 50%?
Yeah. Okay. Now, we have a result in each one. We want to divide by 4. Let's double check. You have an objection? Which one? Do you have an objection to 1, 2, 3, 4, or 5?
3.
3%, 50% colorblind female. How many of those females are colorblind?
0.
Why?
Because capital R, lowercase r,
Right.
you're still a tetrachromatic.
This is a carrier. So for a female to be colorblind, you have to have lowercase on both. You have to be fully lacking the gene. If you even have one gene that's a capital R, you have regular rods and cones, and you have enough of them to see regular color vision. In fact, you might have super color vision, because that little different gene actually gives you a little extra information in addition to the regular information. So that's a carrier. This is trichromate. Now, I have phrased these as percent colorblind male, and you go, oh, none of them. Percent trichromate male, and you go 1, 2 out of 4, and you go 50%. There's other things that people sometimes, the English of this can get a little bit confusing, just to give you a heads up. If I said a sentence like, what are the odds that if it's a boy, genetically, that it's colorblind?
0.
And what are the odds that if it's a boy, it's trichromate? 100, because I've taken that odd out, so I'm only looking at these two results. So if a sentence starts with if it's this, you are taking out some of the possibilities. Because you're already presupposing it's a boy, or you're presupposing it's a genetic girl.
I'm very confused.
Yeah? Which one? Oh, well, this one,
I don't understand this.
these two, there's no colorblind females. That's 0%. We just corrected that. Because both of these are carriers. You have to have 2 of them for recessives.
Okay.
For number 4.
So, but no. It might be, I just want to, because we did get an answer like that, and I also want to address, if we were doing, say, brown eyes and blue eyes, to pick one, with capital B is brown eyes, and lowercase b is blue. What color is that?
Brown.
Yeah, and what color is that? And what color is that? Brown. So, if I have that, are they colorblind?
Yes. No. No.
No. And if I have that, are they colorblind?
No.
No. If I have that, are they colorblind?
Yes.
Yes. So when we have this case, that's known as a carrier. But if you have this, are they colorblind?
Yes.
Yes. If you have this, well, hold it. You said yes.
Oh wait, no. Capital Y. No.
Okay. No, they're not. And if I did this, are they colorblind?
Yes.
And if I did this,
Yes.
I made a typing mistake. That's insane.
Okay.
The Y chromosome literally looks small and stunted because it's missing all those genes. It's gotten smaller over the years. You'll sometimes see people that'll write reports, and you'll see amazing headlines like the Y chromosome will disappear in like 60 generations. That doesn't make any sense. It has shrunk and expanded in our genetic history several times. It is the method that our species uses to genetically determine gender. It's only genetic gender. One of the reasons that we think that there's lots of people who experience gender in ways that aren't genetic, and their genetic gender doesn't match what they feel that they are, and how their brain works and everything else, because it's all just a matter of hormones and genes and all mixing together. If you're a frog, and we take out all the female frogs, and we put them in a separate pen, and they're all celebrating because they're like, "Hey, we're going to have a party all together," and then all the male frogs are like, "Whoa, we're all together." And you wait some time, half of the male frogs will turn into female frogs. They don't determine their physical gender based on their genetics. It's not set that way. They will switch depending on their environment. So if they're in you're looking very surprised. Can you imagine if you went to like an all boys or all girls school and then halfway through the year, half the students just switched genetically and physically their gender? That would be amazing. There's no reason that can't happen for humans because all we need to do is add some extra genes into the Y chromosome, make it as robust as the X, and determine gender based on environmental factors. It's not that hard for the frogs to do. The reason we can't is because the Y is lacking all those genes. So if you try and make a YY, it just doesn't work. It's missing so many genes that the result would be entirely sterile. But if you add those genes back, then you could have a different mechanism controlling what your genetic gender is. You could just base, for frogs, it will often depend on, like when they're in the little pools and they're growing, they just goes by temperature markers. If they're in a slightly cooler pool, I believe they go male. The slightly warmer pool, they go female. And that is random enough that they get roughly 50-50. But also, if they're experiencing a ton of hormones from other frogs of the same gender, they just switch. Because it's really advantageous. If you are a frog, and you're a frog, female frog, and a bunch of females, well, that's not going to give you a lot of progeny. But if you switch into a male, now you're a male frog and a bunch of female frogs, and vice versa. So they just do that. So the way we do it is one particular way. Other species don't do it the same way. Yeah.
Can you go up one slide there? I have another.
Oh, is there another objection?
Yeah, because it's trichromate female, but 50%
Oh!
of the females are trichromate females.
Right. So how many are trichromate females?
50%.
No. Oh, right. If it was female, it would be 100%. Hold it. No. How many of the females are trichromate females?
Well, 100%.
No.
Of the females are trichromate.
No. How many of the females are trichromate females? 0. I don't think that question is on here. That's trichromate male.
No. But if you go down, second to bottom, number 4.
There we go. 0%.
But if you have,
These are carriers.
Because it's too
Isn't
I said at the beginning that I was using trichromate to mean not a carrier. I'm realizing if I give you this as a test question, I should probably be more explicit, like genetically.
because
yeah.
trichromate means that it's
Yeah.
okay.
Trichromate can mean you have regular color vision. In this context, I also mean, because if you're a carrier, I've said you're a carrier.
Okay.
Yeah. Hemophilia is one of the reasons. Have you heard of the expression for royalty being a blue blood?
Yes.
And do you know what hemophilia is?
Is it an incest?
Oh, man. Genetics does have a lot of incest in it.
Was that a good omen or a bad omen?
No,
I'm gonna go write down some notes.
just to,
Because like royalty.
hemophilia is an inherited blood bleeding disorder in which the blood does not clot properly. Leads to spontaneous bleeding, as well as bleeding following injuries or surgery. Often when you lack clotting factors. Oh, how many of you have heard that if your blood is deoxygenated, your blood is blue?
That's wrong.
That is absolutely false. I was told that by my biology 12 teacher. And when I hit university in biochem, and I said that to my lab tech, he kind of giggled and made fun of me for my bad biology knowledge. So I've been there. And I also didn't believe them. I'm like, I've been taught this in high school. So I went to my chemistry lab, and I took, I had like nitrogen. Some chemical experiments you can only do under nitrogen, because if you do them under an oxygen atmosphere, it'll blow up on you. So I had an oxygen tank and a plastic bag that nitrogen would go in, it would exit the other side, and you had gloves you could put in and then manipulate the chemicals. I set one of those up, put my hand in, tied the plastic band tight around my arm, peeled back the plastic, and cut myself in a nitrogen atmosphere. So most of the blood at the surface is deoxygenated. And if it hits the oxygen in the air, my thought was that's why it's always red. You can see it. But if I want to see the blue stuff, I needed nitrogen. Always red, no matter where I cut on my hand. It's always red. So if you were taught that, it's because books like to make deoxygenated nitrogen blue so you can see where it is. But it's only a diagram artifact. They lied to me. Hemophilia, people with this were referred to, their blood would come out a slightly more purple color sometimes, and so it would look a little different. And so they were referred to as blue bloods, and it eventually became the slang for royal blood because hemophilia popped up in a royal family. From a mutation, we're pretty sure, because you can do this as an exercise for class. You get the royal family's bloodline because we've traced that. It's one of the families we've traced extremely well. We know not only who was married to who, we know who had an affair with who and had an illegitimate child with who, because you needed to know that to know who would inherit what. And so we have very good records of royal families, and they're all inbred like crazy. Because if you want to make an alliance with the other country, then your children would have to get together, which means all of a sudden you're related. And then when their grandchildren want to cement that alliance,